Welcome to solverfy.
So we can say that the resistance of the loop R is going to be equal to the resistivity multiplied by the length over the area. So this would be equal to 1.69 times 10 to the -8th ohms meter, and then multiplied by pi times 0.10 meters, and then divided by pi times 2.5 times 10 to the -3rd meters quantity squared divided by 4. And at this point, we can say that the resistance is going to be equal to 1.1 approximately times 10 to the -3rd ohms. At this point, we can use that the current I would be equal to the induced EMF epsilon, the absolute value of the EMF epsilon divided by the resistance. So this would be equal to the absolute value of the change in magnetic flux with respect to time according to Faraday's law. And then this would be essentially multiplied by 1 over R. And so this is going to be equal to pi R squared over R multiplied by the absolute value of the change in the magnetic field with the change in the magnitude of the magnetic field with respect to time. And so when we solve for the change in the absolute value of the change of the magnitude of the magnetic field with respect to time, this would be equal to the current times R over pi R squared. We can now solve 10 amps multiplied by the resistance that we calculated initially, 1.1 times 10 to the -3rd ohms. And then this will be divided by pi times the radius of 0.05 meters quantity squared. And we find that the absolute value of the change in magnitude of the magnetic field with respect to time will be 1.4 teslas per second. This is our final answer. That is the end of the solution. Thank you for watching.